Hello, welcome to our discussion today. Today, we want to discuss how to solve complex numbers. Learning objectives 1. To understand what complex numbers are, learn how to add, subtract, multiply, and divide complex numbers. Solve basic problems involving complex numbers. And to practice solving problems in complex numbers step by step. So, what is a complex number? A complex number is a number in the form a plus bi, where a is a real part and b is the imaginary part. A complex number is a number in the form a plus bi, where A is a real part and B is the imaginary part, and I is the imaginary unit, and I is the imaginary unit, and I square equals minus 1. I square equals minus 1. So this iota is the imaginary unit, and the iota square is equals to minus 1. Examples of complex numbers 3 plus 2i. An example here is minus 5 plus 6i. An example is 0 minus 7i. So in our discussion, just permit us to rephrase to this symbol as I. We call it iota as well. Some literatures, they call it iotas. So a complex number on a plane looks like this, where the horizontal line is the real axis and the vertical line is the imaginary axis. Now, in our normal Cartesian plane, we do refer to this in elementary level as y-axis and the horizontal line as the x-axis. But in complex number, we will refer to them as imaginary axis, that is the y-axis now. And this horizontal axis will be referred to as the real axis. So when given a complex number to add, say we are asked to add 3 plus 4i plus 5 minus 2i. What do you do? The first step, group real parts and imaginary parts separately. So in that case, we'll have 3 plus 5 plus 4i minus 2i. Step 2, add real and imaginary parts. So we'll have 8 plus 2i. So the final answer is 8 plus 2i. The final answer is 8 plus 2i. So we take another example, subtracting complex numbers. Given these complex numbers, we are asked to subtract. Subtract 7 plus 6i minus 2 into bracket 2 plus 4i. Step 1, you have to group the real part and the imaginary part separately. The next step, when you do that, you'll have 7 minus 2 plus 6i plus 4i. So, step 2, subtract real and imaginary part. So the result will be 5 plus 2i. 5 plus 2i. Next, we consider multiplying complex numbers. Example 3 now. So when you multiply these two complex numbers, what will you do? You expand using distributive property. You expand the complex number using distributive property. So in this wise, you multiply the real part. This is what I will do. I will multiply this bracket by 2 plus multiply this other bracket again by 3i. That's what I'll do. Multiply this bracket by 2 and also multiply this bracket by 3i. So looking at this, that's what is happening. 2 times 4 plus 2 times this times 3i plus times exactly what is happening here. So when you compute that, you will have 8 minus 10i plus 12i minus 15i square. Remember the I square was minus 1. So step 2, combine like terms. You combine like terms. So when you combine like terms, you will have 8 plus 2i minus 15 times minus 1. I've told you where this minus 1 is coming from, that the I square, according to our divination, equals minus 1. So we have minus 1 here. That is the imaginary unit square gives us a minus 1. So we now have 8 plus 2i plus 15, because minus 15 times minus 1 is plus 15. We sum it to arrive here. So our final answer is 23 plus 2i. Our final answer is 23 plus 2i. So now the next example is to consider division. Division of complex numbers. So we are given this complex number for us to divide. The first step is to multiply numerator and denominator by the conjugate. You multiply the numerator and the denominator by its conjugate. So looking at this, the conjugate, looking at the denominator, the conjugate is 1 plus 4i. The conjugate is 1 plus 4i. So we are to multiply the numerator by 1 plus 4i, same goes with the denominator, and this is what we have. This is a multiplication. The given problem times the conjugate, 1 plus 4i divided by 1 plus 4i. So next is to expand the numerator and the denominator separately. We are to expand the numerator and the denominator separately. So when you expand it, you will have, as we did in our previous example. So when you expand it, you will have this as a result. You expand, you multiply, you have this. So simplify. So when you simplify, you arrive at minus 5 plus 14i. That is for the numerator. So we go to the denominator. For denominator, you will have this. Like when we talk about difference of two square, we will have this here. 1 square minus 4i square. So when you simplify it, you will see you will have I square will turn to minus 1, and you will now have 1 times minus 16 times 1. Minus, so you first treat this part, minus 16 times minus 1, you will have 1 plus 16 equals 17. So the final answer should be written in this form. So by writing a final answer, you separate the imaginary part from the real part. So we have minus 17 divided by 17 plus 14 divided by 17i. So that is what you will have. So now By now, you should be able to solving these complex numbers. So you can try this yourself. That given this, you have to add these two complex numbers. Another example for you to try. Given this, 6 plus 2i minus 1 plus 7i. To practice yourself, there's another example you should try. 1 plus 3i and 2 plus 4i. The products of these two complex numbers. This is another one you should try to divide. So we have considered here this here as well. Given the problem, 4 plus 3i to add to 2 minus 4i. You will do that component wise. When you do it component wise, you will arrive at 4 plus 2i plus 3i minus 5i. Adding them component wise, that is real part to real part, imaginary part, you will have 6 minus 2i. So 6 minus 2i is the expected answer. Solution to 2. We have here 6 plus 2i minus 1 plus 7i in bracket. So just like you treated that of the addition, you will do so to the subtraction. So you collect your term component wise and simplify. So when you do this, you have 6 minus 1 plus into 2i minus 7i. So that's what we are having here. So the result is 5 minus 5i. Remember to keep your results in these formats. Solution to 3. This was a given problem. We had to multiply these two. Same component wise. When you multiply, you get these results. 2 plus 4i plus 6i plus 12i squared. So I squared is minus 1. So that's why we return minus 1 here and simplify again. We have minus 10 plus 10i. Now solution to the fourth problem. Given the problem, we should multiply, find the conjugates. The conjugate here is 2 plus 3i. So we have to multiply the numerator and the denominator by 2 plus 3i. So that is what we are doing here. So when you do that, you multiply the product on the numerator separately. So when you multiply the product on the numerator, this is what you will have. You simplify it to arrive here. This is I square. So you need to treat this I square. You need to treat the I square. So when you treat it, you now have minus 1. So 3 times minus 1. When you simplify this line, you will have 17 plus 7 plus 17i. Now we head to the denominator and simplify. We multiply the two products in the denominator. That is 2 minus 3i and 2 plus 3i. So when we do that, this is what we will have. When you simplify, you arrive at 13, and which gives us the final operation. So at this point, we arranged our result in the form of real parts plus the imaginary parts. So what do we learn from this? Complex numbers have a real and imaginary part. Complex numbers have a real and imaginary part. When we add, subtract, multiply, and divide them systematically, when we add, subtract, and multiply them systematically, we should take note of this imaginary equation. We should take note of this and always look out for it to ensure that it is well applied, because after applying it, that we can move forward. So as you can see, in complex number, we can add, subtract, multiply, and divide them systematically. So always remember that I square is equals to minus 1 when simplifying. Always remember that I square equals to minus 1 when simplifying. Practice helps you become faster and more accurate. Take note, practice helps you to become faster and more accurate. So thank you. I believe you have learned something today. Keep practicing and you will master complex numbers. So if you have any question on complex numbers from this our discussion, drop it on the comment section. And if there is any example you want us to treat, also drop it in the comment section. Also, if there is any other topic in mathematics you want us to consider, you are free to drop it in the comment section. Then we will go through it and give you feedback. Also, if you have learned something from this our discussion and you want your friend to also have something to learn too, you are free to share our discussion on complex number with them. Also, you can go through our previous teachings, videos are there. There could be one or two of them that you may want to learn new thing. You are free to go through them and learn. You can see one or two things to learn from them. And if you have questions, you are always free to drop it in the comment section for us. Thank you till I come your way again. Thank you.